In this video, we will continue investigating areas enclosed by polar curves. And in this example, we're going to look at a slightly different question. Instead of just one polar curve, we're going to combine together a region enclosed by two. Specifically, the region that lies inside the curve r equals root 3 sine theta and outside the curve r equals 1 plus cosine theta. So if we go back to a previous example, root 3 sine theta is going to be this circle that opens along that positive vertical axis, and r equals 1 plus cosine theta is going to be something we call a cardioid, because it looks like a heart. And you can go through and use our methods we've discussed for sketching polar curves to come up with this picture. Now, we're going to go through the calculations and see why these two curves intersect when theta equals pi over 3. But first, let's indicate the region that we want to find. We want to find the region that lies inside the circle and outside of the cardioid. So inside the circle, but not in the cardioid. So roughly speaking, something that looks like this. So let's find this kind of angle or theta value where they intersect. That would be, where does the square root of sine of theta equal 1 plus cosine of theta? And this is a common problem encountered in, say, a pre-calculus or trig course. And when you're dealing with something like this, with sines and cosines present, a nice way to work with it is to square both sides so that you can hopefully write in terms of one of the trig functions. So if these two quantities are equal, their squares are also going to be equal. So on the left, we will have 3 sine squared. And on the right, if we expand out, we would have 1 plus 2 cosine theta plus cosine squared. And we can get this expressed solely in terms of theta of cosines if we rewrite the sine squared in terms of its Pythagorean identity. So sine squared is 1 minus cosine squared. And now we should be able to rather efficiently solve for theta. If we bring all of the terms to the right-hand side, we'll have 0 is equal to, we'll have 4 cosine squared of theta plus 2 cosine theta, and then 1 minus 3 is minus 2. So 0 is equal to a 2 that factors out, and then this would be 2 cosine theta minus 1 multiplied by cosine theta plus 1. So cosine theta equals 1/2, or cosine theta is equal to minus 1. So that would give us theta equals pi over 3, and theta is equal to pi. Now note, in terms of calculating the enclosed area that we've indicated, that enclosed area is going to come from finding first the area enclosed from pi over 3 to pi with that circle, but that will include this extra crescent shape. And then what we'll need to do is subtract that away. So just giving ourselves a bit more room to work with here, the area enclosed is going to be from pi over 3 to pi, so that goes back to the theta values we determined. We're going to have a 1/2 out front from our formula. And the first thing I'm going to do is find the area enclosed by that circle. So that would be the square root 3 sine of theta squared. And once we have that, it's giving us a bit too much area. We have kind of this red bit which is extra, so we have to subtract that away. So minus, and the 1/2 is still going to hit that, the area enclosed by the second polar curve. So minus 1 plus cosine theta squared. So we're first finding the area which is a bit too much. It includes that extra red crescent shape. and then we subtract away the area of that red crescent shape. So let's go ahead and calculate this value. So the 1/2 is out front, and what we need to do is just expand everything in the integrand. So this would be 3 sine squared theta minus the quantity, if we expand this out, 1 minus 2 cosine theta minus cosine squared theta. And then as we've done previously, we're going to rewrite the sine squared and the cosine squared in terms of the double angle formula for cosine. So this will become 3/2 the quantity 1 minus cosine of 2 theta, so just using the double angle formula, minus 1 minus 2 cosine theta, and then subtracting away 1/2 the quantity 1 plus cosine 2 theta. And at first, I agree with you, this looks like a complete mess, but if we really focus in on what's happening inside this integrand, we do get some nice cancellations. So for example, note positive 3/2 minus 1 minus 1/2. So those three numbers vanish. Minus 3/2 cosine 2 theta. Then we have minus 1/2 cosine 2 theta. So together we have a minus 2 cosine 2 theta, and then the only remaining term is minus 2 cosine theta. And these are two fairly reasonable functions for us to integrate. So anti-differentiating individually, we would have minus sine 2 theta, because the antiderivative of cosine 2 theta is 1/2 sine 2 theta. Then we would have minus 2 sine theta. And we need to evaluate from pi over 3 to pi. So replace each theta we see with a pi, minus sine, replace it with a pi over 3. And note, when you plug in pi, sine pi is 0, sine 2 pi is 0. So it's only the pi over 3 that gives us a non-zero quantity. And if you do the algebra and simplify, this ends up being 3 square roots of 3 over 4.